Good morning, students. In this session, we are going to discuss about the basics of demineralization by ion exchange process. The learning outcome of this ion exchange process involves. Definitely at the end of this session, your students will acquire knowledge on ion exchange process and the chemistry involved in the purification techniques, and can acquire knowledge on types of resins and its role in purification techniques. Raw water supply. Water comes into sites from many sources and can be potable, suitable for drinking. An industrial supply provided by the local water plant or the clients or supply extra on site from a river or borehole. The drinking water use is sterile and includes many of the natural elements we need to sustain a healthy life. All these ions, however, cannot be left in the water fed to boilers and to other processes. They would cause corrosion and deposit, affecting performance and causing premature plant failure. 4 principal types of supply are widely encountered. Number 1. Groundwaters. Pumped from borewells or wells, these supplies have a high salt content. From deep borewells, the water quality remains very constant and it is normally high in hardness, particularly calcium and magnesium ions, and high in alkalinity, that is due to the presence of bicarbonate ions. Normally, dissolved organics are not present. Number 2. Surface waters. Upland sources low in dissolved solids but with the high proportions of dissolved organics, and lower levels with moderate dissolved solids with a moderate to high organics. Mix of surface and groundwaters of variable quality. Normally, the ions present in all natural waters is segregated to cations and anions. Let us have a discussion regarding the cations. The majority of the cations involved in the natural waters are sodium, calcium, magnesium, potassium, and iron. And the anion involves bicarbonates, sulfates, chlorides, nitrates, silicon. In addition, dissolved organics can be present, which can be important on some sites with regard to resin selections. The typical plant designs involves to achieve a high water quality. The majority of the plant employed fit into the following categories: cation and anion, that is the main subject for today's presentation. A polishing cation, mixed bed, reverse osmosis. The cation and anion columns can employ either co-flow or counterflow regeneration, and in some cases they can also employ a degassing tower after the cation unit. Generally, in demineralization process, softening alone is insufficient for most high-pressure boilers, feed waters, and for many process streams, especially those used in the manufacture of electronic equipments. In addition to the removal of hardness through the resins, these processes require removal of all dissolved solids such as sodium, silica, alkalinity, and mineral ions. And demineralization of water is the removal of essentially all inorganic salts by ion exchange. In this process, strong acid cations resins in the hydrogen from converts dissolved salts into their corresponding acids, and strong base anion resin in the hydroxide form removes these acids. Demineralization produces water similar in quality to distillation at a lower cost for more fresh waters. What is the actual principles of demineralization? A demineralizer system consists of one or more ion exchange resin columns which include a strong acid cation unit and a strong base anion unit. The cation exchange resin exchange hydrogen from the raw water cation, and the anion exchange the remaining ions from the system. Let us have a detailed discussion regarding the ion exchange resins. Synthetic ion exchanger requires certain properties to perform demineralization. The 3 main properties required are insoluble but permeable by water, an ability to exchange ions with the different types of ions commonly encountered in water supplies, active group throughout the beads perform the ion exchange to allow the passage of water through the resin bed at optimum rates without undue pressure drop. Classification of ion exchangers. Ion exchangers are broadly classified into strong cation exchanger, weak cation exchanger, strong anion exchanger, weak anion exchanger. Again, under strong cation exchanger, sulfonic acid resins. The sulfonic acids are nothing but SO3H groups. And weak cation resins or carboxylic acid resins, that is nothing but COOH functional groups. And strong anion exchange resins is quaternary amine resins. It is nothing but the nitrogen atom gets surrounded by 4 alkyl units or aryl units. And weak anion is nothing but tertiary amine resins. Tertiary amine is nothing but nitrogen atom gets surrounded by 3 alkyl or aryl units. And the commercial name of all these resins are listed here. Example for strong cation exchanger is Dovax 50. Example for weak cation exchanger is ambolite IOC 50. Example for quaternary amine resins is Dovax 1. Examples for tertiary amine resins are ambolite 2 or 4B. Again, these strong acid cation resins can neutralize strong base and convert neutral salts into their corresponding acids. And strong base anion resins can neutralize strong acids and convert neutral salts into their corresponding bases. These resins are utilized in most softening and full demineralization applications. Weak acid cations and weak base resins, particularly ambolite as well as ambolite IRC 50. They are able to neutralize strong base and acids respectively. These resins are used for dealkalization. The concept of dealkalization is nothing but the system should have a tendency to remove the alkaline material present inside the system. That is nothing but material responsible for exhibiting pH greater than 7. And partial demineralization, or in combination with strong resins, full demineralization. Strong acid cation resins derive their functionality from sulfonic acid group. As I stated earlier, sulfonic acid is nothing but SO3H. When used in demineralization, strong acid cation resins remove nearly all raw water cations, replacing them with hydrogen ions. The exchange reaction is reversible. When its capacity is exhausted, the resins can be regenerated with the excess of mineral acids. Strong acid cation exchanger function well at all pH range. There is no specific restrictions. These resins have found a wide range of applications. For example, they are used in sodium cycle for softening and in the hydrogen cycle for decationization. Weak cation exchange resins derive their exchange activity from the carboxylic acid group, that is nothing but COOH. When operated in the hydrogen form, weak acid cation resins remove cations that are associated with alkalinity, producing carbonic acids. Weak acid cation resins are used primarily for softening and dealkalization of high hardness, high alkalinity waters, frequently in conjunction with soft acid cations, sodium cycle polishing system. In full demineralization system, the use of weak acid cation and strong acid cation resin in combination provides the economy of more efficient weak acid resin along with the full exchange capabilities of the strong acid cation resins. Next, of more particular, strong cation exchange resins. The two basic principal types of resins is weak acid cations, strong acid cations. As I stated earlier, here I highlighted the major functional group that is responsible for the exchange process. When the system is getting exhausted, it can be regenerated by using excess of dilute acids such as sulfuric acid or hydrochloric acids. Here we highlighted the reaction involved in the exchange mechanism. Here the resin is nothing but sulfonic acid SO3H and Na, sodium. Here this hydrogen is easily ionizable, hence this SO3H replaces the sodium ions and left behind the hydrogen ions. Similarly, the second molecule of resin is getting involved in the swapping of cation. So in this way, it removes almost all the cation in the systems. And of course, there is some selectivity in removing the ions. Here I highlighted the selectivity of ions. All the resin is having a tendency to remove ion in a more faster rate than calcium, then magnesium, then potassium, then sodium. And this depends upon the nature of size as well as the electronaffinity character. In the regeneration process, as we discussed earlier, usage of acid is utilized. The sodium salt of sulfonic acid resin is treated with HCl so that the Na get exchanged with the chlorine and H get replaced the portion of sodium. Similarly, the calcium salt is get replaced by the hydrogen and the calcium is get converted in the form of calcium sulfate as a byproduct. And the remaining untreated acid, without affecting the system, it can be easily removed from the process. And the treated water contains high concentration of H plus ion, so water exits cation at a low pH. Anion resins. Strong base anion resins are employed on all demineralization plants for producing high quality water, either in separate anion units and or as the strong base anion component in mixed beads. Strong base anion resins will remove all anions present but require an excess of sodium hydroxide to regenerate them. Let us have a discussion regarding the chemical reaction involved in anion unit, exchange resin unit. In service operation resin. A resin contains amine groups that is having a tendency to replace the anions such as chloride ion and sulfate ions. The chlorine ion occupies the position of OH group from the anion resins. Similarly, the sulfate ion also replaces the position of OH in the anion resins. And again, just like cation exchange resin, here also it follows some selectivity order. And the trend is always the sulfate ions have more priority than nitride, then chloride, bicarbonate, and the least is silica. When the system is getting exhausted, we have to switch over to the regeneration process. The resin is treated with the sodium hydroxide. Again, the system is getting reversed by replacing the chloride ion by the hydroxide ion and sulfate ion by the hydroxide ion. And the treated water now contains excess of hydroxide ion, which combine with H plus to form a pure water. Ion exchange resin beads. The standard grain resins from all manufacturers are typically around 300 to 1200 microns, with less than 1% less than 300 microns. Hence, internal system nozzles are selected to have a maximum slot aperture of 200 microns. The 6 most important factors affecting resin selections, and this is one of the important factors in this part. While designing the ion exchange process demineralization mechanism, this 6th point is important in selecting the resin unit. Raw water quality, this TDS and other contaminants, treated water quality, conductivity and silica specifications, engineering techniques employed in co-flow or counter-flow regeneration, operating flow rate, it's a good kinetics, process temperature. Anion resins have low maximum temperature limits, and process of organic foullants. And this is the co-flow is the counterflow regeneration process involved in the system is displayed. With the counterflow regeneration, the most highly regenerated portion of the ion exchange unit is at the unit outlet, so leakage is significantly better in service operation. The regeneration of resin involves the following main steps. With co-flow regeneration is backwash, bed settle, establish motive water, regenerate, injection, slow displacement rinse, fast rinse. And it's a flow diagram regarding the co-flow regeneration, and we highlighted the parts in the system, that is inlet, outlet, and drain, all those things. And this is the overall process involved in the demineralization process. Here we are passing over hot water containing the ions, and once it passes over the cation exchange resin, it will remove almost all the cations, example cation, calcium, sodium, all those things. The cation free water is again pumped to the anion exchange resin compartment, where all the anion impurities get trapped by the anion exchange resins, and the pure water is passing through this outlet and then collected. Suppose if the resin is getting exhausted, here we are having another compartment of acid regenerator. From this we are passing a HCl to regenerate the anion cation exchange resin, and here we are having an alkaline regenerator. From this we are regenerating the anion exchange resins. That's all about the demineralization process. Thank you.